Hello everyone, welcome to our new video. So before getting into the topic, I want to say that we are currently undergoing 100 days coding challenge in our channel. And if you are new to our channel, please subscribe and join our family where we code and learn multiple new things in daily basis. Now let's get back to the topic. Our problem of the day is split array largest sum. So let's see the problem statement first. Given an array of n elements and the number k, split the given array into k subarrays such that the maximum subarray sum achievable out of k subarrays formed is minimum possible, and find that possible subarray sum. So this problem is categorized as hard, and before starting with our logic, let's see some examples given. Here in the first example, our number of elements, that is n is equals to 4, and k given is 3. So according to the quotient, we can split our given array to 3 subarrays. But we have to find the possible subarray with largest sum. So in the first case, the array is 1, 2, 3, 4. If we divide this subarray in 3 parts, we can divide it in 1, 2, then a subarray with single element 3, and the last subarray with single element 4. And among these 3 subarrays which we have divided, we have to find that subarray which has maximum sum. So if we add 2 plus 1, we got 3, and here in this subarray we get 3 as a total sum. In the last subarray the sum is 4, so it is the largest or maximum sum. Thus we will return this, and the output is 4. In the next example also, we got 1, 1, 2, and we have to split this array in two subarrays. So if we divide 1 and 1 as an subarray and 2 as a single element subarray, we can see the output of minimum length subarray with maximum sum is 2. Thus we have returned 2. So I hope we are clear with our examples. Now let's see the time and space complexity. Given in the question, the auxiliary space is big O of 1, so we can't allocate any memory to solve this problem. So to make this video crisp and much informative, let us take this smaller example first and then decide how to approach to this kind of problem. So in our first example, our k value is 2. Thus we have to divide this given array into two subarrays. Generally, to solve this kind of problem, we allocate memory to make our problem easier, but in this case we can't allocate any memory. So let's try a different approach. So what we can do is we can follow the binary search algorithm, where we will calculate our low, and the low in our case will be the maximum element present in our array. In this example, 2 is the maximum element present, so we will initiate our low with 2, and our high will be the sum of all the elements present in our array. So that is 2 plus 1 plus 1, we will get 4. Now as we calculate mid in our binary search, we will calculate the mid value, and our mid will be 2 plus 4 by 2, that is 6 by 2, we will get 3. So if you are aware of a binary search, we find the element is less or greater than the mid value, and if the element to be found is greater than mid, we update our low by mid plus 1, and if the element to be found is less than mid, we update our high by mid minus 1. So we will perform the similar approach in this program. We will keep on iterating in our given array and add up all the elements. And once the sum of element is greater than the mid value, we will update our count. The count will indicate the possible number of subarrays in by our given array. So let's continue with the process and see whether we are getting our correct output or not. We will store our sum of every element in a variable, and we will also take a counter variable which will store the count of a subarrays. So in the first iteration, we will add the first value of our array, that is 1. So sum is 1, and we will check the sum is greater than 3 or not. If it is not, we will iterate further and add the next index, that is 1 plus 1, 2. 2 is also less than 3, so we will iterate further, then we will add 4. Now our sum is greater than the mid value. Thus we can say we got two subarrays of sum less than the value of mid. That is, the first subarray is 1, 1, and the next subarray will be this individual element 2. So our count will be 1 plus 1, that is 2. So we can see our count value is less than the mid. So as we have discussed, what we do in binary search, when the element is lesser than the mid, we update our high value by mid minus 1. So same thing we will do. Now our low will be same, but our high value will be updated by mid minus 1, that is 3 minus 2 is 2. And also we know in binary search algorithm, our final value is stored in the mid variable only. So what we can do is, here we can take an variable res which will store the minimum between the res and the mid value. So in first case, we can say our res is equals to 3. We will initiate our res with the maximum value, and thus the minimum between the res and the mid will be 3. So our value will be stored in a res variable. Then we have to update our high, we have did it, and accordingly our mid value will be changed. So mid is equals to high plus low by 2, that is 4 by 2 is 2. Now again we will perform the sum of every elements in our array till the sum is greater than the mid. So let's take a sum variable again. At first, the first value will be stored, that is 1. So 1 is less than mid, then we will iterate in the next index and we will add the next value, that is 1. So 2 is also not greater than 2. We will again iterate in our array and we will add the last index value, that is 2. So we get 4 which is greater than the mid value, and thus we will update our count by 1 for the first subarray and also for this individual subarray whose value is 2. So thus the final count value will be 1 plus 1, that is 2. Now again we can see our count is 2 and the given mid value was 2. And according to binary search algorithm, what we have discussed in previous iteration also, we have to update our high value. So high will be mid minus 1, that is 2 minus 1, that is 1. And now we can see our high is 1 and the low is 2. So we will stop our iteration over here. And by now, finally, we can see we have two subarrays. That is true, right? One subarray is 1, 1, and the other subarray is 2. Finally, we will get this only. So as we have done our iteration, we will simply update our result value by the min value between the result, the previous result, and the current mid value. So our result will be 2. The current mid value was 2. So we will return 2. So this is our final output. So this is all about the logic. Now let's quickly dive into the code. So as we have discussed, we have to take two variables, low and high. And in low, we were storing the highest value present in our array, and in high we are storing the sum of all the values present in our array. So for that, we can take low is equals to, and we can initiate our high with 0. Now let's run a loop, because to calculate the sum of all the elements we need a loop. So we will start from 0th index, it will iterate till the nth index, and we will increase our I by 1. In each iteration we will find the maximum value, math.max, between the present value of low and the current index I. This is how we will find the maximum element in our array, and to sum up all the elements we will keep on iterating and add all the elements of ith index. So that was pretty much simple, and now we will take a result variable where we will store our final result. Let's take it integer dot maxval, and according to binary search algorithm we will iterate till our low is less than equals to high. In each iteration we will calculate a mid value, so mid was equals to low plus high by 2. This is how we calculate our mid. Now to check if k numbers of subarrays is possible by a given array or not, we can define a method, that is if is possible. So it will return us 0 or 1. If it is possible, it will return 1, and we will continue with our statement. So we can pass our array the value of n and the value of k along with the mid value. We will pass this, and as we have discussed, if it is possible, we will update our result value with the minimum value between the previous result value and the current result, that is stored in mid. So res comma mid. And also we have seen that if it is possible to create k subarrays, then we were updating our high value, and if it is not, in that case we will update our low value. But if it is possible, let's update high with mid minus 1. And in the else part, if we can't create k number of subarrays, we will update our low by mid plus 1. And at last, when we are done with our iteration, we will simply return our calculated result value. So this is all about the logic. Now we have to simply define this method is possible. So let's create the method stat. We will take an array, then the value of n that stores the length of the array, value of k which is given in our quotient, and the calculated mid value. And now we have to take a counter which will calculate the total number of subarrays, and also we have to take a variable which will store the sum of all the elements. So let us create those variable int count equals 0 and int current sum equals 0. So to sum up the elements of the array, we will take a loop where we will start from the 0th index of the given array. It will iterate till n, and I will be increased by 1. We will store the sum in our current sum. And for each iteration, we were checking if the current sum is greater than the given mid or not. So let us do that also. Current sum is greater than our given mid or not. If it is true, that means we found an subarray. So we will increase our count value by 1. That is pretty much simple. And in the current sum, we will store the value of our current index. So why we have stored this value? If we see in our example, the sum was greater than the mid value at the last index of our array. So in that case, we will stop our iteration. But what if there are more number of elements in our array? Thus, in that case, we have to store the value where it actually exceeds the mid value. That is why we have stored our current index value when the current sum is greater than mid. And at last, when our iteration is completed, we will increase our count value by 1 for the last subarray we found. Let us see the example again. Here, this at first we have added our count for this subarray, that is 1 and 1. And after the total iteration, when we are out of the loop, we will increase our count value for this subarray. So hence we will get two subarrays in total. That is a simple logic. That's why we come out of the loop and added our count or increased our count by 1 for the last subarray we found. And then we have to return. So it's a boolean type method. So we will return either true or false. So let's give a condition if the count value which we have calculated is less than equals to k or not. K is the maximum possible subarray we can build, which is given in our quotient, and count is the possible subarrays which we have calculated in this method. So if this is true, if the count is less than the given maximum value of subarrays in our quotient, then it will return true and we will update our high value. And if it is not, that means k number of subarray is not possible. In that case, we will update our low by mid plus 1. So this is all about the program. Now let us check whether it has any issues or not. Math.min between, okay, it will be result and mid. Okay, so it was subarray and the current sum. So we have checked our program and I think we are good to go. Let's compile and run now. Compilation completed, so we have no errors in our program. Let's submit our code. Yes, so our code has successfully passed all the given test cases and also satisfy the given space and time complexity. If you find this video helpful, please like, share and subscribe this video with your friends, and let us meet in the next video again. Thank you everyone. Happy coding.